Welcome to this second event of the Maths Meets Arts Festival here today on Tuesday over a late lunch, I would say, but it's never too late to do some maths and arts. So let me quickly recap, where are we or where were we? So the festival has started yesterday with two very interesting talks about mathematics and games. We saw the development of a mathematical game based on algebra, and then we have seen a mathematical garden with minimal surfaces and how to explore them and how to learn information, how to gather information about them. So today in the Maths Meets Art Festival, we focus on math and music, and this briefly lunch event is called Chapter Zero. This is gonna be a brief overview of what we try to do in this project. So before I dive into it, let me just quickly remind you that if you need extra information about the event, you can find everything on the website here, Maths Meets Arts. This is a shortened version. And that, of course, as you may be watching us, we are live on Twitch. If you want to interact with us, you're welcome to do so. You can just write comments in the Twitch chat. And today, Catherine, the organizer, the leader of the Maths Meets Arts event, will be monitoring these. And so any questions will be answered. And finally, if you prefer to use another platform, you can also ask questions on Facebook. For that, just go to our webpage there, Maths Meets Arts, and from there we have a dedicated channel for today's event. So now, without much further ado, let's move to Maths Meets Music. Let's move to this Chapter Zero, and let's start with a bit of a background. So how did this start? When did Maths Meets Arts start? So more or less everything started last year when Catherine decided to invite artists to develop sort of new ways to communicate mathematics to the public. And I have to say the response to that was quite significant. Funnily enough, it is kind of something they have in common, mathematicians and artists. They often work with abstract concepts and they try to communicate abstract concepts and engage with the public. So this is really a note in common, and it turned out to be a very, very prolific and successful collaboration, because very soon, quickly afterwards, 3 projects popped up on the common theme of minimal surfaces. Now, what is it? What is a minimal surface? What is a mathematical surface? Just to give you an idea, we can see here in the bottom right corner something that I would call a mathematical surface. So what is it? It's, if you look at it, it's like a 3-dimensional object. We can clearly see this guy lives on the table and occupies some space in 3D, but it has a 2-dimensional flavor. It looks a bit like a piece of paper wrapped up and just made beautiful. And this is just to give you a brief idea of what is a mathematical surface. And these kind of mathematical objects are what sparked these three projects that happened. And the 3 projects were The Sounds of Surface by Jenny Hibbert and Andrew Johnston, The Infinity Core by Lee Allatson, and The Countless Deformations by Chloe Alijani. Now, we will learn more about the Sounds of Surface project in a minute. Just bear with me. And let me just say a few words about the other ones. The Infinity Core is a sound and music project based on rough surfaces, and we will learn more about it in the coming days. Whereas the Countless Deformation is a dance performance. It's just amazing, and this will happen tomorrow evening. So join us tomorrow if you want to learn more about it. So about last year, what happened is these projects were presented in 2 separate events, one at the Attenborough Arts Center and one at the Henry Wellcome Building. And the public, I have to say, just loved it. And if you want to know more about it, what I can do now is I can invite you to have a look at the May issue of the newsletter of the London Mathematical Society, where they host an article by Catherine about this event, about what happened there. with a bit of mathematical details for the ones who have more of a background in that. But this is also very useful for the general public. If you want to know more about it, go and have a look there. And so now what I want to do is I want to say a few words about this Sounds of Surfaces project. Here we see a picture from the event. And in fact, we have even a snippet of what happened there. So let me try to give you an idea of what they tried to convey there. So with this installation, the artist tried to investigate and portray the mystery and the very interesting mathematical information that is hidden in these beautiful surfaces. We see one of these beautiful, meaningful surfaces here. And these objects, they are not just like aesthetically pleasant, they contain also a lot of mathematics. But it's quite difficult to communicate these mathematics. And the artists found a unique way to explore these and help the audience navigate it. So what they decided to do is to portray the unknown as a dark chamber, and the knowledge is something that you need to discover by reading neon writings on the wall and using tailored lights. And the whole event was truly remarkable. Let's have a look at it together to give you a feeling of what happened there.
Yeah, exactly.
I've got to run, unfortunately. Yes, so I've got to go and
Imagine when you come and all of us are stepping way back from the sound.
Yeah, it does.
As you can see, it was quite engaging, and you can imagine you were like in a dark room with a light, streaming light on the wall, and trying to understand more about this beautiful object, which was glowing in the dark. And I have to say, I would like to comment here something that I find very, very interesting as a mathematician about the artist's decision, because the artist decided, as it is very plausible to say, to portray the unknown as darkness. So the unknown is darkness, and the known things is white writings on the wall that you need to find. No, you need to discover it. Now, as a mathematician, this is exactly the opposite of what I would imagine, because for me, when I'm involved in my research, for me the unknown is a blank piece of paper. It's everything imaginable. You have a blank piece of paper in front of you, and you want to do some maths and write some maths on it. And when you write the maths, you write it with a pencil or with a pen. So you write with dark on white, whereas here the artist portrayed exactly the opposite. So the specular colors. And I think that the fact that you can portray the unknown in these two very opposite ways, and yet they're both consistent, I find this very, very interesting. And so maybe before moving to the next slide, let's watch this again together, and maybe now also focus on the background voices, because this helps bringing a mystery and a surrounding to the whole experience. So let's just have a look at it once again.
Yeah, exactly.
You can close your eyes and
No worries.
Yes, so I've got to go and
imagine what's happening
Imagine
there.
when you come and all of us are stepping way back from the sound.
Yeah, it does.
Very, very interesting. And I have to say, tonight we have the honor of hosting the artist, and they will let us know more about it. So if you want to know more about this very interesting installation, join us today, 7:30 p.m. But now, let's come to the present. And what is the present now for the Maths Meets Arts? Well, now the team is called Maths Meets Arts Tiger Team. And as you can see here, it involves a big collective of mathematicians and artists, all working together on several different projects in different directions to try to engage more and more with the public. And in this whole ensemble of projects, there are two that are dedicated to mathematics and music. So one of them, the blue one, is the Sounds of Surface. So the artists are bringing this experience further. They are further developing this experience. This is by Jenny and Andrew. And the second project, this is completely new project, is the Sounds of Soap Films, and I'm part of it. And with me on this project, we have Wayne Rossman and we have Lee Allatson. So to conclude, I just want to say something about this to give you an idea of what we are trying to do that. So let's start with the title. So we call this project The Sound of Soap Films. And now the first question is, what is a soap film, right? Like first we need to understand what we are talking about. So Sounds of Soap Film sounds complicated, but let's start with the end of the sentence. What is a soap film? And the best way to describe what is a soap film is to use a beautiful picture. So here I picked this one from Wikimedia Commons. So this has been taken by Alina Wozna and is available on the web. And here we see what is a soap film. So a soap film is nothing but a thin layer that you can create by mixing water and soap. And then it creates these beautiful shapes with beautiful reflections. And I'm sure you have all seen these kind of objects in the past months or past years. And now what I want to do is I want to study, or what we wanted to do is we wanted to study the sounds of these soap films. And if you find these confusing, don't worry, you're not alone, because it is not very clear what is the sound of such an object. So to be honest, so up to today, I've never managed to listen to such an object. And yet, from a mathematical perspective, I can imagine what is the sound, or I can speak in a certain sense about the sound. So you may very well want to know, what does this mean? What is the sound of this object? And the way to explain this, it takes a bit of time. So we will give a description of this evening. So you're welcome to join us. But now let's say you accept, you're here with me and you accept that these things have a sound in a certain sense, whatever that means. Now, let's try to use a bit of imagination. If you think just like for a second about it, you immediately get many, many questions, because it sounds like a crazy thing. No? So like, for instance, if we are talking about sound of this object, then we know these objects, they just a bit of wind, they change the shape. So then the natural question is, how does the sound depend on the shape? This is a very interesting and a very difficult question. And then another question that you may ask yourself is, so we're talking about sounds, but are these nice sounds? Like, are they aesthetically pleasant? Would we want to listen to these sounds if we could? And that's also a nice question, which makes me ask another question. Because if you ask me, are these nice sounds? Then I may ask you, what is a nice sound? So we all have experience of aesthetically pleasing sounds. We can think of birds chirping in the morning, or Tibetan bells or harps. These are all beautiful sounds. But if we had to describe these to an alien and say, what is a beautiful sound, then it's not easy. So this required also a discussion. And if you want to know more about these things, as you see, a title, ton of questions, trying to explore this very abstract concept. I invite you to join us today, 7:30. So we are moving toward the end of this lunch event. Let me just invite you to provide some feedback. If you want to share something with us, just go to the website and then click on the top right corner. You see we have a page with written feedback, and it's a very, very short form, just 2 pages. It will take you less than 3 minutes to tell us if you like this, if you didn't like it, what we should do or what we shouldn't do. We welcome any kind of feedback. And so to conclude, let me bring it to the end. I just tried to give you a brief overview of what we try to do about maths and music in Ms. Maths Meets Arts Festival. If you want to know more about this, join us today at 7:30 p.m. where we will discuss more in details the sounds of soap films and the sounds of soap projects. Otherwise, all the information, if you need anything, is on our website. We will be live on Twitch tonight, where you can ask questions and engage with us. Similarly, you can ask questions on Facebook. So with this, I would like to conclude. I would like to thank you for your attention. Have a great afternoon, and I hope to see many of you tonight. Many thanks. See you later.